Hello friends, this video introduces about HiPS tool which is developed at the Department of Computer Science and Engineering, Shinshu University. This tool is mainly designed to analyze the petri nets. HiPS tool is developed in C#, C++, Bush Container and Intel TVV library using Visual Studio. It runs in Windows environment. You can name the elements of places and transition. Places can set initial marking and capacity. The weight of the arc can be set. Here, from File menu, you can create new canvas, save the created net and open the saved nets. In Edit menu, the functions like undo, redo, copy, paste, cut and delete are available. From Tool menu, various functions like indices matrix, structural properties and behavioral properties are implemented. To get more information about HiPS tool, you can read the manual from Help in menu. By pressing any of the place, transition and arc buttons, you can place the elements by clicking in the canvas. Here, you can scale the canvas. It is possible to select and move any element. Here is an example for random walk simulation using HiPS tools. You can simulate the net on canvas. Fireable transactions are also randomly chosen. Automatic simulation is also possible. You can adjust the shape of simulation. You can pause the simulation and then you can operate the firing step by step. When the system stops, the screen turns into white and returns to the initial state. From the menu table, you can display the indices matrix as table. And also you can analyze T-invariance and S-invariance for structural property. In this video, you can see analysis of S-invariant. By changing the color, you can display the support to an invariant. You can perform analysis on structural properties like safe, repetition, and bounded only within this video. A reachable graph can be generated for a given bounded net. Output is in Aldebaran format. For a given unbounded nets, you can generate coverability graph and an extended coverability graph. In the extended coverability graph, it is possible to represent the transition to the marking in which the number of tokens of the covered places is restored to a natural number. Deadlock can be analyzed by specifying the depth of the reachability tree, and you can see the firing sequence from the initial state to deadlock state. The synchronic distance is displayed in the table. If it does not fit in a finite number of times, it is displayed as infinite. In the case of be fair or unconditionally fair, the result is displayed below the synchronic distance table. For the implementation of state space generation engine, you can select single thread or multi-thread. State space generating is performed for making from initial to reachable marking. Thank you for watching this video.